So we'll wait for until 8:05. So all the participants will join. Until then, if you have any questions regarding the last 5 sessions we did, just let me know into the comment chat box. Sorry. So guys, here is the dashboard. Like if once we will log in into this academy.3dash.com, once you will log in into this platform, you have to go to this icon that you will be able to see here. Then click on it and go to my purchases, right? And from there, if you click on your course, purchased course, you will see something like this, where you will be able to see all the day 5 contents with the recordings uploaded in each day. So these recordings will be available for up to 365 days. If you want to explore, you can just go into the dashboard and you can check it out. And since these recordings are being redirected from the YouTube private videos, so if you are having problem or difficulty in accessing this video through the dashboard, you can let me know into the WhatsApp group. I can make this video public so you can easily access from my channel as well. But right now these videos are private. This means to access these videos, you have to log into your dashboard and you will be able to come here to watch these recordings. So if you want to make it easy, I will definitely run a small poll about this into the group. Like if most of you will agree that I can share these videos under public category on YouTube, so all of you can easily access the video, then we'll do that. So it's on to you guys. So right now we are active into this day 6 session, that is SolidWorks engineering drawing and BOM. So this is the thing that we are going to learn today. And so far until day 5, all video has been uploaded. So I think you are learning a lot, you are practicing a lot while watching these videos. So how many of you had tried something into the SolidWorks till today? Just let me know into the chat box. Just write I into the chat box if you have tried something into the SolidWorks. If you have installed it, you had made any part or any assembly into the SolidWorks so far, just let me know. Just write I into the chat box. I know it's Sunday, so it will not be easy for every one of us to be into these meetings, but I can see there are almost 10 members have joined. So not 10, I think 8 members have joined so far, so that's good. So guys, let me know into the chat box how many of you have tried SolidWorks so far. And all the time, if you have any questions, write into the chat box. At the end of this session, you will get a chance to ask your questions by unmuting yourself. But now you can simply ask into the chat box. Just write into the chat box any queries, any questions until today. So now we are here for this day 6 session, and today we are going to learn SolidWorks engineering drawing and BOM, right? So how we can create drawings from our parts or assemblies inside SolidWorks, and how we can no, today is not last. There will be one more session where we'll be doing a small mini project. In the session, maybe tomorrow, we'll be doing a small mini project. We'll start from simple part file, then small assembly, and then drawing. So it will be a kind of recap of everything that we have learned during these 6 days. And again, every step that we are taking, everything that we are doing is getting recorded right now, and you can have access to all those contents into your dashboard. I was just posting a small poll inside the group, so all of you have to vote into that, like whether you want all the recorded session to be public onto YouTube, so you can easily access those videos and contents. You don't have to log in into the dashboard each time to access those contents. So guys, we basically came here to learn how we can create drawings, perfect drawings inside SolidWorks in this video. So here you can see, this is the day 6 session, and It is a 1 week bootcamp, so one more session will left, and that will be about the mini project that we'll be doing tomorrow. So let's dive into our SolidWorks directly, and let's see what we can do and how we can start creating our drawings or designs, right? So I will go back to my SolidWorks, and here is my SolidWorks. So in the last session, we have already finished the assembly, right? We had included three components in a single assembly file, and I explained you about like how we can uh, insert the first component into the assembly file, how we can align it properly with respect to the coordinate systems or the origin, how we can make it fixed or moving across the space, how we can mate other part with other components using different mating features. So these are the things we have learned in the last session. So if somehow if you have missed the last session, just go into that recording and check it out. It's a very informative session. You will be learning a lot about assemblies and all those things. But today we are here to like, and what I think the drawing and this session, today's session, is the most important session, because whatever the things we are designing, the end goal is always to create drawings from it. So we can share those drawings to the floor people who are working on the machines, who are doing the machining work, who are doing the welding, soldering, whatever. So the end goal is to share the drawings with them so they can convert our drawings to actual products using different manufacturing technologies or the processes, right? So creating drawing is the most important thing. How you can create a drawing so it can communicate with different level of people, right? Because sometimes what happens, like when you create a drawing, that should be readable by everyone, because in a team it's a very general thing that all people are not like educated for on the same level. Like the foremans or the normal staff who are working in the workshops, they are not very well educated, right? But the people who are sitting onto the top, they have good technical knowledge, they have learned engineering and all those stuff. But the end of the process, the drawing always go through them, right? Through the foreman or through the floor manager. So they should understand what is the thing, what are the features you have created inside the drawing, and they should read your drawing very easily. That's why creating a drawing that should convey, that should transfer all the information is also important. So this is what we're going to learn today. So let's open the assembly file first that we created into the last session. So we'll go on to this home tab, and let's say this is the drawing we created. If you remember this benchwise.sldasm, right? So I will open this one and it will open the assembly file. So how many of you remember like what is the file extension for the assembly file? Can you write into the chat box? Just write into the chat box what is the file extension for the assembly file, and also write what is the file extension for the part file. Just write into the chat box, everyone, what is the file extension, because that would, yes, Naidu is right. It's for the part file. SLDPRT is for the part file. Similarly, write what is the file extension for the assembly file. Yes, others is right. It's SLDASM. Not you have written right SLDASM, but for the part file, there is no dot and there is no space. Straightforward SLDPRT, right? So these are the two file formats we have learned so far. But today, the thing that we are going to create is the drawing file. And anyone in the chat box, right? What is the file format for the drawing file? Do you know? Just let me know. Do you know? Anyone know what is the file format for the drawing file inside SolidWorks? No, not DWG. It's DWG is for AutoCAD software. Correct. Naidu is correct. It's SLDDRW is the file format for the drawing file. And this is the thing that we are going to create today, drawing files. So that's why I asked earlier, if you are already aware, it will be easy for you. So here you can see right now we have opened the .sldasm file, right? Benchwise.sldasm. And what I will do to convert or to create drawing from this, so I can share with the workshop people, I can share with anyone to my client or anyone. So they will be able to read all the dimensions and details, because everyone do not have SolidWorks. And if I want to convey all the information into this model to someone who doesn't have SolidWorks, we have to share a normal PDF file, right, with all the technical details like the measurements and everything. And for that purpose, we have to create drawings. So here you can see this is our assembly file. It has four components right now, not four, sorry, three. I think four, but fourth one is somehow hidden. So let me turn it on. Okay, so there is so much problem into this assembly file. Anyway, so if it had, you can see there are lots of errors. So in that case, either you have to start from very beginning, because to solving those error is super difficult in tools like this. So you can estimate, like when we have only 3-4 files, we are having this much of problem. If we could have more than 20 or 50 files, it could be super tough. So you can see the errors are all gone. We'll check again. No, the errors are again there. We'll go on to the home tab again, and we'll see if we can open some other assembly, just to give you how we can learn the drawing file. So I will try to open the simple assembly. Let me see if we have, yes, this assembly that we created, and in the last session, and here you can see this is it is only having 2 parts, right? 1, 2. So now we'll learn how we can convert this to drawing having 2 parts, right? So what we have to do, when you have opened the assembly and saved your assembly file, the next thing that you have to do is simply go on to this file option menu over here, and there you will get an option that says make drawing from assembly, right? All of you can see it, right? Make drawing from assembly. So what you have to do is click on this make drawing from assembly, and it will take few seconds to prepare. Now a window will pop up like this at the center of your screen, where you have to define the size of the paper, right? Because if you want to print it, there are only 4 to 5 standard paper sizes available in the market, and it generally starts with A4 size, the normal paper that we use in our printers, then A3 size, bigger than that, then A2, A1, and A0. So normally all the engineering drawings are printed in A3 paper sizes. So here I will select the A3 paper size. Here you can see I will simply select the A3 paper size, and by default these are some standard drawing formats are provided by the SolidWorks. So if your company, let's say you are working in X ABC company, right? And if your company is using some customized SolidWorks drawing templates, then you can click on the browse, you can find that template and you can use it, right? But by default, SolidWorks is already providing this many drawing formats. Here you can see. So in these drawing formats, I will go with the A3 ISO kind of file format, right? And I will select that A3 paper size with ISO standard. And for A3 paper size, here you can see the size also. For A3 paper size, the width is 420 and height is 297. And this is the standard size. So if you are an engineer, if you're working on a drawing and design space, so I always prefer that you remember the paper sizes also, because all these paper size for A3, the size is 210 by 297. So if you remember these sizes, it will be easy for you to plot your drawing in the right scale for your vendors, clients, or for other departments, right? So I will select the A3 over here. I will press OK. And the moment I will press OK, here you can see this is the template I got that is being provided by the SolidWorks by default. Here you can see. And since I started this drawing from our assembly file, that was, and if you remember, the assembly file that we used was with a name. Here you can see what was with the name assembly1, right? AAACM1. The name was this thing. So in the drawing file also, you can see automatically it is taking the drawing number as AAACM1. But all these things we can customize. So the first thing what we did, we had selected a pre-prepared file format, pre-prepared drawing format provided by the SolidWorks, and there I selected the right paper size that is needed, And that is, let's say we have a printer that can print A3 papers, then we'll use this paper format. If your printer cannot use or print on A3 paper, only capable on A4 paper, then select the A4 paper size. So here I selected A3 because engineering drawings are generally printed on A3 paper sizes. So here you can see, now what we have to do is onto the top, here you can see a new tool panel just got added that says drawings, right? So before changing anything, like here we can customize everything. For example, here you can see the borders are added by automatically into this drawing format. Also this title block. So I hope all of you are aware about this thing, title block. What is title block? So title block is a kind of boxes or a kind of combination of multiple columns and rows where you have to provide all the standard information related to engineering drawings, right? So right now you can see these are all the standard columns that is being provided. For example, title. Whenever you are creating engineering drawing, you have to provide a title. You have to provide drawing number. You have to provide the scale. You have to provide the sheet number. You have to provide the paper size. You have to provide other information like who have created this drawing, who have approved this drawing, on what date it got approved, what is the material of this part that you have created, what is the overall weight of it. So all these informations you have to provide, right? And that's why we call it title block, because if you added the title block into your engineering drawing, any person on the first glance will see this title block and will have an idea like in this drawing what you are trying to talk about, what is the part name, what is the exact information that you want to communicate. So all those information will be into this title block only, and then there will be all the views and everything that will be putting into this space. So this is what we got. So we can edit this title block. So if we'll go on to the right, once you imported your first sheet template into the SolidWorks as a drawing file format, on the left side, right, you will be able to see again the design tree. But this design tree is a little bit different because we are right now into drawing space. So here you can see this is the drawing kind of all options over here. So if you'll expand this one, here you can see it has all the things like borders. This is for the borders. If you want to customize your borders, you can make a right click and you can delete the border, because borders are usually like this only. You cannot change it, right? You can either keep it or delete it. That is the thing. Now then there are other information like bill of material, family table, whole table, and this stuff will be adding further. But right now here you can see this is the thing, right? And then on the top there is an annotation tab. So if you make a right click on the annotation tab and go on to the details, you will be able to see like these are all the annotations that will be visible into your drawing. So these are all by default, so I'm not going to change anything. I will simply press cancel. Now on the sheet format, if you'll make a right click, here you can see it says edit sheet format. So let's click on this edit sheet format. So this is my sheet and this contains this title block and all the boxes and everything. So if I'll click on edit sheet format, here you can see now I can make edit into my title block also. So let's say here you can see the drawing number is already provided. Let's say here I want to add some other information. So I will just double click on it and will change the information. Let's write detailed, or let's write bench wise, right? Bench wise, because this drawing was about bench wise. Once done, just click anywhere outside the space. And let's say here you also want to add like a revision, right? So you have to, since here we don't have that any text over here, so we can simply click on this note tab, right? And not note tab, we have to find the text from where we can add the text over here. So we have to add the revision over here, right? So we can add revisions. How we'll show you. Just come out of this thing, right? And okay, just go on to the edit sheet format, and I will copy this A3. I will select this text. I will press Control C, and then I will come out onto this space. Will press Control V, and then I will copy this revision. And in this revision, I will just double click on it and will change this to, let's say it's 01. So this is how we can do. So we can customize this complete template, but few things are connected with my sheet automatically. For example, here you can see wherever you will be able to see this dollar symbol, this means these are already connected with my actual model. So you don't have to edit anything into this. So whenever you will update your model, these informations will get updated, right? So you don't have to change these details. And once you are done, simply click on this exit editor, sheet editor, and you will be back. So here you can see now our sheet we have updated the title and we have updated the revision, right? If you need, you can also update the name over here, signature or date. It's completely on to you, right? And materials, as if you have seen over there, the material and weight is already connected by default with our part. So once we'll start importing the part into this sheet, these numbers will automatically populate, right? So now let's start adding some view onto our drawing. So we'll go on to the drawing space, drawing tools panel, and the first thing that you can see is the model view. Can you see that model view, everyone? So to insert that model view into our drawing, simply click on this model view, right? And then here you can see, here is I can click on the browse and I will find for the 3D model that I'm going to create a drawing over here. So in this case, I think we are using this assembly.sldasm, right? So I will click on open, and the moment I will click on open, if I'll click anywhere onto the drawing space, your first view just got projected. Can you see that? Now, since I had not pressed any key other than this, not even the escape key, so you can see if I will just move to the right of it, I will be able to create the side view of this drawing. If I will move my cursor towards the bottom, I can create the top view of this drawing. So this is the parent view we just created. Now the other views that will create, if we'll click on the right, you can see the next view got created. If we'll click on the bottom, the next view got created. If we'll go on the corner position like this, isometric view will get created like this. So let's say instead of creating this view, I will go towards this side and will create a view like this, right? And once you are done, simply press escape on your keyboard, and here you can see now this view I want to just keep onto this place so I can move it, because isometric view is almost free to move. But these two views that is being defined with this parent view, so if we'll try to move this one, these two views will also be updating its position, because these two views are projected view of this parent view, right? So if this is a front view, let's say this is a front view, this would be the side view and this would be the top view, right? And this is isometric view. Now, so if you'll make any changes to the parent view, for example, if I'll select this view, and the moment I will select, I will be able to see all the properties related to that view, right? So in these properties, here you can see the main thing is their display style. So right now for this view, the display style is this one. Here you can see this one is active, right? So this is called hidden lines removed view, right? So if we'll change this to this one, so here you can see all the hidden lines are also visible. For example, the hole onto this part and the threads are also visible. But if we'll change this to this one, you can see this is getting more complex, right? More hidden views are visible. But if we'll change this to this one, it will start looking like an actual model we created. So based on your preference, if you want to save color or if you want to save ink onto your 3D printer, you can use different kind of views. Here I will simply select this one. Here you can see this one with wireframe option. So I will select this wireframe option and I can use this view. Now, apart from the display style, and since this was the parent view, and since I changed the parent view, all the other views are also getting changed, right? But if we'll change any other view, for example, if I'll change this one only, not the parent view, the other views that is driven by the parent view, if we'll change the visual style of it, it is not affecting the other views, right? So all the time parent view will be the father and these are all the childs of it. So if we'll make a change into the father, the child style will also get updated. But if we'll make a change in the child style, it will not affect the other file and other childs, right? So it's important to understand that chronology. Now here you can see in this assembly, this part is not correctly aligned. Here you can see it's moved little bit. So that will be correcting in a second. But before that, let me show you some more things. So what we did, we had changed the visual style for this one. So all the other got updated. But when we changed for this one, the visual style for the others are not getting affected, right? Again, select any part. Apart from this display style, the next option is this scale. So if you'll see your drawing space right now, the scale right now is 1:1. And that's why when I projected this part into this drawing, the scale was 1:1, right? And here also you can see the seat scale was 1:1. So whenever you are importing any drawing views, the scale is always 1:1. So let's say, for example, for this view, I don't want this scale. Let's first change the view of this view, right? I change the visual style to this. And for this one, let's keep this one, the default one, for like for the every other part. Or you can click on the parent style, right? Like this. Let's say for this view, once I will select this view, I want to change the scale. I want to make it a little bit smaller. So how we can do that? Just select your view, go to the scale option, and instead of use parent scale, change this to custom scale, right? Now if we'll change this to 1:2, and we'll click outside, here you can see the size is getting reduced. So based on your preference, like how big you want to keep your parts into the drawing space, you can adjust the thing. But once we will make a change into the parent view, the other will also get changed, right? So it's important that whenever you are changing to the parent views, adjust the other views as well, right? So I will change this back to the parent scale, right? Here you can see 1:1. Apart from this, so this was about the scale. Now the dimension type will always keep projected. We're not going to change that. And then the cosmetic thread display will keep default quality, draft quality. We are not going to change that. So these are the things that is good. I will click on finish. So now apart from this, let's say if you want to change the scale for the complete drawing sheet. Right now the scale for this complete drawing sheet is 1:1, right? Let's say I want to change the scale for the complete drawing sheet. So how we can do that? We'll make it right click on the sheet format, and we'll go on to the edit sheet. Sorry, I will go on to the properties, right? And the moment I will go on to the properties, here you can see right now for this sheet that we created, the scale is 1:1, right? Let's say I want to make it 1:2. And the moment you will click on apply changes, here you can see all the views got updated to scale of 1:2. So this way you can adjust the scale of your complete sheet using the properties from this sheet option, right? Here I will bring it back to 1:1. Apply changes. Also, let's say in the middle of your drawing creation or the design creation, you had figured it out that I don't want to work with A3 sheet format. Now I want this sheet format to be updated to A2. So how we can do that? Again, the same process. Go onto the properties panel by making a right click onto this option over here. And there you can change your paper size. Simply select A2, click on apply changes. Yes. And here you can see it just got updated. But the moment you will change the paper size, all the edits that you did inside the title block will get removed, right? So again, you have to feed all the information again, whatever the edits or the things that you have did into your drawing. So just remember that. I will press Ctrl+Z. I will just press Ctrl+Z, whether we can go back or not. No, we cannot. So again, we'll go back to the properties panel and we'll change this to A3, right? So A3 was the sheet file format I was using. So you can see what we did. We had inserted the first view, that was this view, and then we projected that view on this direction towards the bottom and one isometric view. So to display any part, usually we need 3 different views, right? Now, this was a complete drawing for the assembly, but we had not added any information like the whole details or the size and everything. Now, see, since we added all the views into a drawing, so first thing I will do, I will click on the save option over here. So the moment I will click on save, here you can see I had saved this one. it is getting saved with a file extension called SLD-DRW. So all the time inside SolidWorks, if anyone asks you what is the default file format for the SolidWorks drawings, it is SLD DRW. DRW for the drawing and SLD for the SolidWorks, right? For the part file, it's SLD PRT. For the assembly file, SLD ASM. For the drawing file, it's SLD DRW. Simple, right? I will click on save and this will just got saved, revealed and save the document. Now until this point, anyone have any questions? Just let me know into the chat box. Any one of you have any questions, or just write N into the chat box. If you don't have any questions, just write N into the chat box. Just write N into the chat box if you don't have any questions. Okay, great. So here you can see we have added views into the drawing. Now let's say at any point of time, let's say if I'll move this one a little bit towards this direction. So at any point of time, you have felt that, okay, so I also have to project the left side view of this parent view. So how you can do that? Simply go to the drawing space, click on this projected view tool. Can you see this projected view tool? Just activate that. Select your part for which you want to get a projected view. Drag your cursor and click. And then you will get the other projected view. For example, let's say I want to project for this view. So I will activate this projected view, will select this part and will drag my cursor and in a direction, and I will be able to see the projected view for this part. So all the time, if you have option to add projected views, different views for your drawings, right? But if you have learned engineering drawing, if you had studied engineering drawing, almost 3 views are enough to define your drawings. Apart from that, you can add some custom views like the section views or detailed views based on the requirements. But 3 views like the front, top and side view is most of the time it's enough to explain all the details and a specification of your models, right? So here you can see this is what we got. Now the moment we saved this one, here you can see still we have this one part, and I think it's got corrected now, right? Yes, the assembly file just got corrected. So this file, the assembly file just got corrected. So anytime, what I was trying to say, if anytime you'll make any updates to your actual part models, those updates will get reflected onto your drawing instantly, right? If you'll make any change, that change will get added over here. For example, let me add information so you can see. For example, for this hole that you can see over here. So if you'll add the diameter of this hole, let me add by going to the annotation tab. I can start adding all the details. So inside the annotation tab, again, you have the dimension tool. So if we'll click on this and drag outside, here you can see the dimension, the whole size here is right now 516, right? So if we'll click on save, it got saved. So this whole size is 16, right? Now let's go back to that part file. So that part file, let's open that part file. So to open that part file, expand over here, I will expand the assembly. And this is the main body. I will make a right click and will click on open part. So I'm opening the main body. So this is the model, right? And this hole I had just shown you in the drawing, this is 16, right? Let's try to change the size of this hole. So let me find that hole first. Yeah, this is the hole. So I will change the size of it. Right now it is 16. So let's make it 15. 15, enter, right? So here you can see the whole side just got updated into the part file. Now if we'll click on exit sketch. Okay, so it is giving me some problem. Let me check what is the problem. Edit, cut extrude as well. Okay, so it's selecting the wrong profile to cut. So maybe I have to delete this one. Yes, now it is correct. So what we did, we had changed the size of this hole to 15 now. Here you can see 15. I will simply save this part. I will close it. Now we'll go back to the drawing. See, drawing automatically got updated, right? We only changed the feature here, the whole size that was earlier 16, and we made that change into the part file, and here the drawing already got updated. So you don't have to make changes, right? All things are connected inside SolidWorks. So your assembly is connected to your part file, your drawing is connected to your assembly file or your part file, right? So all the time, all details are connected. Now, the next thing, this is, we also want to add a center line for this hole, right? Because if someone will see, they will not be able to get whether it's hole or something else. So for that, there is a tool called center line. Can you see that? Just activate the tool, select both the edges of your hole, and center line will get added like this. Why we added center line is because most of the time the position of the hole is being defined by the center of the hole. So from the top, the center of the hole is 22.6, right? But it's not good to define the position of the hole onto this view. So I will delete this one. I will come onto this view, and here we'll add the center line using this center mark tool, right? So we'll activate that. We'll only click on the circle and center mark will get added. Now here we can add that dimension. So from the top to this horizontal line, this one should be 22.6, like this. So when someone will read this drawing, they will be able to know, like from the top, this center hole position is 22.6 and the size of this hole is 515, right? 515 in diameter. So the 5 symbol is for circular holes only, and this denotes the diameter, right? 5 is the symbol of diameter. Now, what is the overall length of this body? So again, activate the smart dimension tool, select the top is and the bottom is, drag outside and place anywhere your dimension. So this is the length. Here you can see this is the length of my complete drawing, and that is 90 millimeter, because right now we are working in millimeter gram second system of unit. So all the dimensions that here you are adding is 90. But again, I'm repeating, once you will share this drawing as a PDF, and they will not be able to know like in which like unit system of unit these values are added. So to make that simple, you can, these thing are added over here, this note is added over here, and that says dimension are in millimeters. So whatever you are seeing into this drawing are in millimeters only, right? So you don't have to worry about that, because when we started this drawing, we selected the file format, the drawing file format as ISO, right, for the millimeter. That's why. So now you can see we added. Now let's say we want to add information about this hole. What is this hole size, right? So if I remember, we had created this hole using the hole and thread tool, right? So we'll activate this call out feature. You will be able to see this call out feature, hole call out feature, right? This is especially to mark the hole size. If you have created the hole and thread features to create those features into a part model, you can use this feature called hole call out inside drawing space. And the moment tool is active, simply click anywhere onto the circumference of your hole and drag outside. Here you can see what it is saying. It is saying me that here is a through hole of diameter 12, right? Through hole means complete hole, right? Through the complete body. Let's activate it again, and this time I will try to select the thread. So you can see we cannot select it, right? We cannot select the thread. Anyway, so what we did, we had added over here as the hole information, right? Hole call out we just take. Now we'll activate the note tool, and if we'll click on the thread, we can also include the thread information, but we are not going to do that, right? And let me see. Yes. Now, as we know, this complete assembly we created have two parts, right? One was this holder and other was the main body. But how will someone else will know that which part is which one? How they will know, right? For that, there is a tool inside SolidWorks that says balloons. So first click on auto balloon. So the moment you will click on auto balloon and will click on finish, right? Okay, so first activate the auto balloon, right? Then select your main assembly where you want to add balloons. And the moment you will select and will click on finish, here you can see the balloon just got added. This means this is part 1 and this is part 2. So you can align these balloons so anyone can easily read them, So you can align it appropriately around empty spaces, so anyone can easily read that. So this balloon denotes that this is first part file and this is second part file, right? So we'll move this view a little bit towards bottom, like somewhere. So we are keeping this corner space empty. We'll show you why. Right. So what we did, first we imported this assembly, we added the balloons, then we added few dimensions, right? We only added few dimensions. We are not added all the detailed dimensions, because whenever you are dimensioning assemblies, you only have to show the overall length and width of your model. You don't have to put all the details. For example, here like this, you can add this dimension, like from these two jaw, you always want to keep this distance 40 millimeters. So just add normal dimensions inside your assembly file. Don't ever add all the detailed dimensions, because detailed dimensions are only added on the part level drawings only. And this is not a part level drawing, this is an assembly level drawing that we are creating like this. So the overall width of this part is 51.31. The overall height is 90 and the width is 80. So we have almost defined all the dimensions needed for this assembly. And for this whole details and everything, we can add into the part label drawings, right? Because these holes are specific to the parts, right? That's why. So you can see we added the part balloons also. Now the next thing that we have to add into this assembly file is the what is the let me add the center mark also over here, so it will look good. So we added the center mark over here, we added the center mark over here, we added the center line over here. So these were the things we have to add. And then we have to add the BOM bill of material into this drawing space. And how you can add the bill of materials? It's very simple. Go on to the tables. There is a special tool for that that says bill of material. So the moment you will click on bill of material, right, you only have to select the main assembly view and it will create. And once you will click on finish, it will add a bill of material like this. Here you can see. So what it does, it included information like item number, like serial number. Then the first is the main body. You can, from the balloons, you can see the first is the main body. Second was the holder. So these are the part names, right, that we defined when we created the part. So that's why I say, whenever you're getting a part, renaming your parts are important. Give it a proper name, because that proper name will be getting reflected into your BOM, bill of material. And then you can also add some description and quantity. So for this assembly, the quantity is 1 and 1 only. So here you can see 1 and 1. So if you have more than 100 parts, in that case, these quantities are little bit important. For example, I will show you one of the drawing I created earlier. One of the drawing I created earlier for a client. Let me just open that. Yes. So I'm just opening a simple drawing for you. Where is the SLDRW file? Change this to type. So I'm just trying to find the DRW file, drawing file, so I can explain you. This was a big, you can see this is a very big. Okay, let me show you with the PDF. Here it is. So you can see this is the complete assembly, and next is this is my BOM. So here all the balloons I have shown like this, and then we also explained the part number and the quantity. So if someone is coming and viewing this drawing, they can easily estimate that I'm referring to which part number to which portion of the assembly, right? So this is the benefit of adding balloons and the BOM bill of material, we call it, right? And now here you can see we updated that. And for these two parts, can you see inside the materials it's empty and the weight is also empty? Why? Because for these two parts we have not defined the material and the weight. So let's try to add that. We'll again open our part file, making a right click onto the part. We'll click on open part, right? Let's first open this one. Now let's add the make a right click and change the material of this as plain carbon steel, right? We'll click on save. We'll close it, and we'll also change the material for holder, open part, material not specified. You can see we'll change this to plain carbon style. Let's make it properties, material, plain carbon style, right? So for both the parts, we have changed the material to plain carbon style. We'll update, we'll save, and we'll click on close. So for both the parts, we have changed the material. Now we'll update this one, right? And here also, and also we have to make change into the assembly as well. So we'll also have to open this assembly file. Open assembly file. Yes. Here you can see this is my assembly file. We'll make a right click. We'll go on to and find. So I think it's almost done. So we'll go on to this evaluate and we'll check the mass properties first. So here you can see the mass is coming is 928.22 gram, right? So the mass property is good. We'll close this one. We'll click on update, save, close. Will take few seconds to update. Okay, so now we have to make sure that the bait is getting updated onto this area, but it is not getting updated, right? So we'll go on to the seat, we'll click on the properties, right? Not on the seat, sorry. We'll go on to the edit seat format, right? And here you can see under the weight, the things are not getting updated because here you can see the things are not connected at this moment, because somehow when we change the seat size, we had removed that connection, right? So here is one problem. That's why it's not getting updated automatically. The weight and the material is not getting populated. So that is one of the problems. So always when you are selecting your seat sizes, make sure that you have selected the right sizes. So what we'll do, we'll click on the new seat, right? The new seat, here you can see, we'll go into the properties. Let's change to A3, apply changes. And here into the seat file format, new seat file format, we'll edit it and we'll see. Again, here also we are not getting those options. So maybe we have to do a new drawing for that. Anyway, so we'll open that one again. So what are the things we have learned? We have learned how we can create BOM, bill of material of our part, how we can create detailed dimensions for our assembly drawing, how we can add balloons, and how we can update information into our title drawing. So let's update the information also. Edit sheet format. Let's add the drawn. So here I will copy it by pressing Ctrl C, then paste it, and we'll change this drawn to, let's say, my name, Prashant Kumar, right? So I can update that information. I can write the date as well. I can paste the date information, date box, and I can add the date as well. So let's write the date for the today, that is 10/08/25. So this way I can add few information into our title block. Let's say in the material, if it is not coming anything, we can add our material. Let's write plain carbon steel is the material, right? So this way we can add the information. Once we are done, we can simply come out of the editing sheet format, and here you can see. So this is what we had so far. We had it for the part file, right? This was just a this was just a assembly file for that we did. Now also, if you want to add any sorts of information into your drawing, so just click on this note tab that you can see over here, and let's say I want to write something. I can simply bring, the moment you will click on note, you will see a box. Click anywhere across the space, and let's say I want to add information like this drawing is not for manufacturing, manufacturing. So I can write information like this. So these kind of notes or the text you can add anywhere onto your drawing using this notes tool. And all the time, if you want to change the text size of these notes that you have added, simply select that, and the moment you will select, you will be able to see on the left side like the document fonts. So if you untick this option, go on to the fonts, and then you can control the size of it, the font style, and everything from this option. I'm not going to change this one, but we have that option to change. But whenever you have started with any specific sheet sizes or sheet paper sizes, then you don't have to change these things. So this was all about creating a drawing file for the assembly. I will click on save to this file, and we'll close it. Now we'll try the same with one of the part file, because knowing for the part file is also very important. So we'll go on to the home tab. We'll launch the one part file first, and I will show you how we can create drawing for this part file. Same process. Once you open the part file, go on to this file menu, click on this make drawing from part, click on yes. And since we already created a drawing over here, that's why it's getting opened. I will click on close it first. I will delete that first, so I can show you from the very beginning. For the part file, there is also a drawing. Just give me a second. Yes, I deleted that. And now let's create a drawing from this part. First, we have to select the page size. So I will select A4 this time. I'll press OK. Okay, so there was a problem. When I selected the page in a portrait orientation. I want to get this paper as a landscape orientation. So no problem. I will just close it, and we'll do this again. File, drawing from the part, and here we'll have to make sure that we are selecting the right orientation. So we'll go on to the browse, and we can find the A4 size file format. Here is the A4 size file format, but we want A4 in landscape orientation. Here you can see the A4 in landscape. I will click on open. So now it is looking good. I will press OK. And this is my A4 file format in the landscape orientation. So the first thing is that we'll go on to the drawing, right? Or else you can, what you can do on the right side, can you see these boxes? Here there is a middle box that says view palettes. Click on this view palette, and inside view palette, the main body is selected over here. And if we'll click on refresh, you can see all these drawing views are available over here. So let's say I want to bring any of the view as a parent view. Let's say I want to bring this top view as a parent view. So I will simply drag this and place into my drawing space. So here you can see this view I created as a parent view, right? And still my tool is active. So if I'll move my cursor, it will start creating the other two views that is projected with the parent view. And we'll also create a view like this, let's say like this, for the isometric view. I will click on finish. I will move this view inside the drawing. I will keep selecting it. Will change the visual style for this like this. But here the scale for these are very small. So I will select the parent view. So I have to change the scale for the complete sheet, right? So I will make a right click. We'll go on to the properties. And here I will change the scale to 2:3. I think 2:3. We'll click on apply changes. So yes, 2:3 is looking good onto this sheet, little bit bigger. Now for the whole, here you can see the center lines are automatically created. So I don't have to make it. But for this, here is also a hole, but that hole is not visible. So we'll select the parent view, we'll change the visual style to show hidden edges also. So the moment I will click, you can see the hidden edges also got visible, right? Now first I will go into the annotation tab. We'll apply the center line from these two circles like this. We'll also apply the center mark onto this hole. We'll try, yes, like this. Now we can start defining all the detailed dimension for this part, because on the part level you can add dimensions for each parts. For example, if you carefully see these states, so here you can see we are seeing it perpendicular. So if you want to make a detailed view of this sheet, what we can do, if we'll go on to the drawing tab, there is an option that says detail view, right? So simply activate that detail view, click anywhere near to this drawing and drag outside to get a circle like this. Now you can move that circle and place it anywhere onto your drawing. So what we are getting a detailed view of this A view we had created over here, more bigger, right? You can see the scale for this view is 4:3, whereas the scale for complete drawing is 2:3, right? So this is almost double in size. So now here the things are more visible. Now if you want to add dimensions, we can add, like from the thickness of this is 1, between the two cutouts the distance is 1.91, things like that. So we can add details like this. Also we can activate this tool called hole call out, and we can call out these holes. Like this one is 15 millimeter hole, and this one is 12 millimeter hole, like that, right? So we can add information like this. There you can see. Apart from this, we can also dimensions all the details using this smart dimension tool, where we have the options to add horizontal dimension, vertical dimension. We have also an option to change different dimension styles, like we can do baseline dimensions, chain dimensions, like that. So we have all those options into this drawing space. We also have an options to add balloons, but for a part file it doesn't make sense to add balloons because this is just a single part. But we also have the options to add notes. We can add notes, we can add weld symbols if your part is having any welded feature, but this is a single piece part, so there is no welding things that we have to add. But weldments are a little bit kind of advanced thing that you can start learning by exploring yourself. Apart from that, we also have an options to add surface finish, geometric tolerances, and the things like that. So this was all about, guys, about the SolidWorks drawing. Now if you have any questions, just let me know into the chat box. Just comment if you have any questions. I'm waiting. Just let me know if you have any questions.
Sir, section A, one time.
Okay, so yeah, sorry. So how we can add section views? So if we'll go on to the drawing views, there is an option to add section views of your part, right? So just activate the section view tool, and then here you can see there is an option by default whether you want to create horizontal section or vertical section. So let's say I want to create vertical section. Right now by default the horizontal section is activated. So if we'll activate and change this view to vertical section, and if you'll click on the center of this circle, right, if you'll click on finish, and now if you'll drag, so you can see I'm able to move only in the right and left direction. I cannot move it anywhere around the drawing space, but we want to keep this view over here. So we have to press one time control key or one time control key, and then we can place it anywhere onto the screen. So this view is the section cut view of this view. So if we'll make a section cut along BB axis, we'll get a view like this. So we can also create section views, and once we are done, we can click on finish, and this way we can do. And all the time, if you want to make change out of it, let's say I don't want this section view towards this direction, I mean towards left, I want it towards right. So simply select your section view, right? Press escape, select your section view, and then in the section view properties, flip the direction, right? And the moment you will flip the direction, you can see this is the details we'll get if we'll make a section view from at this particular axis. So this is the view we'll get. So all the things are working instantly across your drawing, right? You don't have to be dependent by making changes manually like we used to do in AutoCAD drawings, right? We have to make changes by thinking from our visualization. In SolidWorks, things are connected everywhere. So at any point of time, if you'll make any change into the part, automatically my SLD, SolidWorks drawing files will get updated. We don't have to do this manually. But PDFs will not get updated all the time. Once you are exporting PDF, you have to re-export it again after the changes. Next questions, how to convert it to manufacturing drawing. So it's a manufacturing drawing. We have to add all the dimensions. I had not added all the dimensions since we are constrained with the time. You have to add all the dimensions. You have to add tolerance, symbols, features, values. So for that, you have to master GD&T tolerance, right? Tolerance concepts. Then you can add all the details and drawings. But this is also a manufacturing drawing with very less detail, but it is.
Sir, more one done.
Yes.
Sir, section B is vertical horizontal with add section of B.
So, sorry, can you please ask again?
Sir, section B, sir.
Yes.
This is for vertical.
This is for vertical. Yes. So see, what you can do, let's
including add and horizontal.
So see, any section view, if you want to create inside SolidWorks, what you can do, let's say I want to create section view, not vertical, not horizontal, at a particular angle. So how we can do that? Once you are into drawing, once you're drawing open in SolidWorks, go to this sketch panel. Let's create a line first at any angle. Whatever you line want to create. Let's say I want to create line like this, and I want this line to be at 30 degrees. So I will define the angle of this line as 30 degrees. So here you can see what I did. I had created a random line at 30 degrees, right? Now what I will do, I will go back to my drawing space, will activate the, I will select this line, right? I selected this line. I will activate the section view. And what it is doing now is it is creating section at that particular line. Can you see that?
Okay, sir. Okay. So, I understand.
Whatever the lines or the sketch you will add, and once you will select that sketch and will activate the section view, you will get details like that, right? So all the time we have complete freedom, like at any angle, at any line, across any axis, we can get our sections. And again, section views are attached with the views, or it will be always perpendicular to the axis. So if you want to place it anywhere onto the drawing, anyone just ask your questions about drawings, because drawing is one of the most important thing. Whatever parts you will create, if you're not able to create drawings, then it's a complete waste. Right? In each companies that you are going to work, if it's not a 3D printing company, you have to create drawings at the end. Because in 3D printings, we don't need drawings. We can simply send our 3D part for the manufacturing. In some cases, we can also send step files, that is 3D files for the CNC cutting. But in most of the cases, they will ask you for the final detailed manufacturing drawing. And when they say details, means adding all the dimensions, section views. Like if someone who don't have idea, if someone who have never seen your part in 3D, they can have the complete idea just by reading your drawings. So this much of information you have to provide into your drawings. So let me know, anyone have any questions? Or else just write in the chat box, because tomorrow will be the last session where we'll be learning we'll be doing a small mini project. Just write in the chat box if you don't have any questions. So I think everyone is clear about what we have learned today. But don't worry, if you have any time, any questions. Yes.
How to circle cut section? How is this possible, sir?
Sorry. Can you repeat it?
Section A drawing, sir. Drawing. Circle okay. A cuts out. How to cut section A? Possible.
Okay, let me open this one. What happened with
circle
this
cut section?
Circle cut section. Okay, so it's very simple. Let's say I want to get a circle section of this area, right? Or let's say I want for this area, because this area is more complex. So I want to do that. Just here is the detailed view. Can you see that detailed view? Just activate that and then point out the center of your circle, and whatever the things that is inside the circle, you will be able to get a cut like this, right? But more enlarged view, if we'll select that, and we can change this to, right now it's no outline, change this to outline, full outline. So we can say it's a kind of circle detail view of this area. Like just keep these values outside like this, right? And then we can add dimensions because this is much more bigger. Are you thinking about that? Talking about that?
Okay, sir. Okay, sir.
And someone is asking what about BOM? BOM simple, I explained you. Simply go to the annotation tab, go to the tables, go to the bill of material, click on it, select your assembly view, because BOM is basically for the assembly view. Select your assembly view, click on finish, and here you can see your BOM is getting attached with your drawing, right? This is the BOM. Like all the time, if you'll select it, you can add the information inside your BOM. Right now, the information is item number, part number, description, and quantity. Only 4 columns. But you have an option to change all those things from these things. Like go on to the configuration or the part numbers. Or so. Okay, so let's go to the bill of material. Here you can see this is my bill of material. I can make a right click onto the bill of material, right? And I can save it as a Excel file format also. So if you click on save as, we can save it as a Excel file. So most of the times, if you want to share our bill of material to purchase department or any other department, we can export that, right? We can export our bill of material to any other departments, right? Any more questions? The BOM of material is very simple. So you can simply insert it from this table. And apart from this BOM of materials, we can also insert these things like whole table, right? So if you'll select this assembly file, we'll click on finish. Okay, so to create a whole, we have to define a datum. And to learn datum, we have to learn little bit concepts about GD and T. And then only you will have an idea what is datum. If you are working on a sheet metal projects, then you can add bend tables, because in what you will usually see when you create a flat pattern out of sheet metal projects, you have to define all the bend tables, like at what place, how much bend is needed, right? Because at the end, they have to fold the sheet metal to get the shape. So these are the things, guys. Any more questions?